Yesterday, we looked at simple harmonic motion, and we said that for a motion to be classified as simple harmonic, it must meet certain criteria. One, that the motion must have a fixed point, that the particle that is doing the simple harmonic motion must have its acceleration directed towards the fixed point. Again, the acceleration should be directly proportional to the displacement from the fixed point. So these are the conditions that must be met for the motion to be classified as simple harmonic. Just as we know with other types of motion, any particle that is in motion, we should be able to find the distance that it covers at any point in time. We should also be able to determine the speed as well as the acceleration. We saw that for a simple harmonic oscillator, the equation for the displacement is given by y is equal to a sine omega t if at t equal to 0, the particle is passing through the equilibrium position. We also have the equation for the displacement to be y equal to a cos omega t if at t equal to 0, the particle is at its maximum displacement. These were the two equations for the displacement of the particle at any point in time. What about the velocity? We also learned that the velocity of the particle during the SHM is given by v equal to omega root of a square minus y square. And then the acceleration is negative omega square y. These are the equations for the motion of a particle if the motion is simple harmonic. Good. We could answer only one question because of time. And I remember giving you an exercise to go and work through so that you'll be able to tell whether you have understood this very well or no. Interesting. Yes, go ahead.
The question says that a particle moving in simple harmonic motion such that a particle is moving in simple harmonic motion such that its displacement y from the equilibrium position at the time t is given by y is equal to 5 sine 0.8 pi t, where
okay, it's all right. You hold on, let me write. Y is equal to 5 sine 0.8 pi t. Is that correct?
Yes, please.
Okay.
Where y is in centimeters.
Where y is in centimeters.
And t is in seconds.
T is in seconds. Okay.
Find I. The amplitude.
So we should find the amplitude. Okay, so now let's pause and then look at what the solution of the question should be. The equation for the particle displacement is y is equal to 5 sine 0.8 pi t. We want to find the amplitude. What should we do? Blessing, since your connection is not that strong, for which reason your speech gets distorted, you can respond by sending a chat. I will read it out, okay? All right, so to the two of you, what is the amplitude? Yes, Cassandra and Jedediah, what is the amplitude?
The amplitude is 5 centimeters.
amplitude is 5 centimeters. Here, amplitude equals 5 centimeters. Okay. Yes, continue. You have found the amplitude. What next?
Now we should find the period.
We should find the period of the oscillation. All right, so how do we get the period of oscillation? Jedediah, you should make some contribution. We have found the amplitude. We want to get the period of oscillation. How do we do it?
The period is equal to 1 over the frequency.
Yes, 1 over the frequency. Period is 1 over the frequency. But we do not have the frequency currently. So what do we do?
So omega is equal to the name 0.8 pi.
We have omega to be equal to 0.8 pi. Okay. What do we do next?
But omega is equal
to
2 pi f.
2 pi f. So it means that then 2 pi f, this is 0.8 pi. So what is the frequency?
0.8.
0.8 pi over 2 pi. Jedediah, if you simplify that, what will you get?
Mhm.
0.4.
You get what? 0.4 hertz. So that's the frequency. Now that we have the frequency, what is next?
The period is equal to 1 over the frequency.
The period of oscillation is going to be 1 over the frequency. So it is 1 over 0.4. And if you evaluate that expression, what would you get? If you evaluate that, what do you have?
2.5.
2.5 seconds. 2.5 seconds. Okay, so that is the period of oscillation. I don't think that these were the only questions that were asked. There could be others. What are those questions?
The displacement when t is 0.25 seconds.
Okay, so when t is equal to 0.25 seconds, we should find the displacement. How do we get the displacement, Cassandra?
Please, the displacement is y is equal to 5 sine 0.8 pi t, and then t is 0.25. So y is equal to 5 sine 0.8 pi 0.25.
Okay, 0.8 pi by 0.25. All right. We need to evaluate, take our time and evaluate that expression. Let's do that one here. What do you get?
So we have 5 sine 0.2.
5 sine, sine what?
0.2 pi.
Oh, do you get 0.25?
Yes.
Cassandra, you are going to multiply 0.8 by pi by 0.25. Does that expression simplify to 0.25?
No, like it will give us 5 sine bracket open 0.2 pi.
0.2 pi.
Yes, please.
Okay, I thought you were saying 0.25. Okay, now yesterday I indicated that the angle in the expression, there is an angle in radian. So we have to program the calculator to see that angle in radian before we do the evaluation. I hope that you have done that. Okay, so if you have done that, what is the displacement?
Please, the displacement is 2.94.
Okay, so you get 2.94 centimeters. That will be the displacement of the particle from its equilibrium position. All right, I want you to go through the solution and then point out any issues that you have, especially with the steps. Okay, so if there are no issues, are these the only questions you were asked to do?
No.
What were the other questions?
And IV, how should find the velocity and the acceleration when t is 0.25 seconds?
Okay, so how do we get the velocity? In the previous page, we had, let me go here, let me go back there. In the previous page, we had equation for the velocity. We also had the equation for the acceleration. And here the equations for velocity is omega root of a squared minus y squared. So that is what we are going to use to get the velocity. All right. So here our velocity is going to be given by omega root of a squared minus y squared. Let's make the substitution. What is omega? We got 0.8 pi. So 0.8 pi root of, now the amplitude is 5. So we have 5 squared. And the displacement at that instant is 2.94. So we have 2.94 squared. Please use your calculators to evaluate the expression there. Jedediah, I hope you are working through the problem. Blessing, I also hope that you are working through the problem as I expect Jedediah to be doing. If you have got an answer, can you put it in the chat box? I'm referring to Blessing.
Yeah, please, I'm coming.
All right, that's fine. Jedediah, are you there?
Yes, sir.
Okay. Can you evaluate the, okay, this, all right, our friend said you got 10.16, that is from Blessing. Let's hear from the rest of you.
What the same thing?
Call out your answer and stop saying you got the same thing. What same thing did you get?
10.16.
10.16. Cassandra, did you get 10.16?
Yes, please.
So 10.16. But you see, velocity is a physical quantity and must have units. If you look at the formula we have used and the substitutions that have been made, what is the unit for the velocity? Yes, I'm waiting for you. What is the unit for the velocity? Oh, what is the unit for the velocity? look at the equation. We have the amplitude in centimeters. The instantaneous displacement is also in centimeters. So our velocity should be in centimeters per second. But it can also express the velocity in meters per second. As it is now, the evaluation should return an answer which is in centimeters per second. All right, that is about the velocity. Let's go to the acceleration. The acceleration is negative omega square y. So we are going to make the substitution. We're going to have negative, the omega is 0.8 pi. So we have 0.8 pi square. And the displacement, we have 2.94. 2.94. All right. Again, our calculators will help us get the value of that expression. Please do that quickly. Yes, what is the acceleration? All right, Blessing has negative 18.57. I think that is what I read. To the rest of you, what are your answers? Cassandra, what have you got?
Negative 18.57.
Jedediah, what have you got?
Negative 18.57.
Okay. I hope that is the end of the question. So let's look at some other examples. Still using the equations of motion. The second question I'm going to put on your screen is this. It says a mass is executing SHM with an amplitude of 0.1 meter. A mass is executing SHM with an amplitude of 0.1 meter and a period of 2 seconds. No, and a period of 4 seconds. Good. A mass is executing the system with an amplitude of 0.1 meter and a period of 4 seconds. Now, question is, deduce an equation. Deduce an equation for the instantaneous. Deduce an equation for the instantaneous displacement. Instantaneous displacement of the particle. Deduce an equation for the instantaneous displacement of the particle from its mean position. If at t equal to 0, the particle was at its maximum displacement. Produce an equation for the instantaneous displacement of the particle from its equilibrium position or mean position. If at t equal to 0, the particle is at its maximum displacement. That's the first question. Then the second question, calculate the time it takes. Calculate the time it takes before the displacement. Calculate the time it takes before the displacement becomes equal to, calculate the time it takes before the displacement becomes equal to 0.075 meter. 0.075 meter. Then the last one, sketch a displacement time graph. A displacement time graph. Sketch a displacement time graph for 4 cycles of the motion. Good. Some time to read through it carefully and see how it should start. So while we go through that, you may have questions you want to ask. I give you the opportunity to do so. Okay. All right. I hope that you have gone through it. Can we look at that together? Jedediah, start for us.
Yeah.
Yes.
Mass executed with an amplitude of this.
You have to speak up a little bit.
So I'm coming. Yeah, please, I want to see, bro. From its main position, if what?
If at t equal to 0,
The
if at
particle.
t equal to 0,
Okay.
the particle was at its maximum displacement. If at t is equal to 0, the particle was at its maximum displacement. So here we are looking for the equation. Jedediah, what do we do? Okay, let's go to Cassandra. Cassandra, I want to derive an equation for the displacement. Yes, Jedediah.
Y.
Mm-hmm. So let me write solution.
Zero.
So y is equal to what?
0.
No, it is not y equal to 0.
There, you said the
Get an
amplitude.
equation for the displacement. Y is not equal to 0.
Hey, so y is equal to.
Okay, so you come again. Let's look at Cassandra's view. Cassandra, what are you going to say as far as this is concerned?
Copy, please. So I think that we'll have to use the equation y is equal to a
Yes, I've written y equal to a. Go ahead.
cos theta.
Is it cos? You seem not to be sure, but that is correct. You see, we have two equations for the displacement. One of them is y equal to a sine omega t. Now we are saying that that equation for the displacement holds if the particle at t equal to 0 was passing through the equilibrium position. We have another expression for the displacement, and that is the a cos omega t. Y is equal to a cos omega t. And we are saying that this equation holds if at t equal to 0, the particle is at its maximum displacement. And I think that is what has been captured in the question. So our equation should be y equal to a cos omega t, but we are expected to put in the value of a and the value of omega. Okay. So what is the value of a here? What is the value of a, which is the amplitude?
0.1.
We have 0.1 sine. Now, we do not have the omega. So I think what we have to do is to get the period. We have the period there. So let's get the frequency and then get the omega. Or in short, we can find the omega. We know that the omega is 2 pi f, and f is 1 over t. So it means that this omega is 2 pi, and where there's f, you write times 1 over t. Okay, so you're going to have 2 pi over t. Now, what is that omega equal to? The value of pi we already know. So we're going to put in 2 pi. The t is the period it takes to make one complete oscillation. Okay, so if the period is 4, then 1 over 4, the frequency is going to be 1 over 4. So this is going to be 2 pi over 4. We can simplify this, that is by putting in the value of pi, get a decimal, or we can also write it as what? Can just write it as 2 pi over 4. Can write it as 2 pi over 4. Yes, as you see there. All right, let me continue on the right. So you now have y is equal to a, which is, yes, Jedediah.
This way, I go over the number 1 again. I don't understand.
Which number 1? You mean the previous question?
So this one you are doing now. When you are done writing what you are done, we are writing.
Okay, so I should go over it. Okay, so here the equation is going to be the amplitude we have 0.1. So our equation is going to be 0.1 cos the omega we are having 2 pi over 4, which is the same as pi over 2. So it can be cos pi over 2 times t. What have I said as far as solving this question is concerned? I am saying that to get the equation for the oscillator, we have actually two equations to choose from. One of them is meant for a situation where the particle involved is passing through the equilibrium position when t is equal to 0. That is, as soon as you begin to monitor the equation of motion, monitor the motion of the particle, you realize that if that moment you start to monitor, the motion is passing, the body is passing through the equilibrium position, then the displacement of the particle should be given by y equal to a sine omega t. Now, if the particle at that instant of it being observed, if at that instant of it being observed, it is already at the maximum displacement, then the equation will have the cos. Now, let's look at which of them has been spelled out here. It says we should find the equation for the motion if at t equal to 0, the particle is at its maximum displacement, which means that we'll have to use the equation that has the cos term in it. All right, so our equation now becomes y is equal to 0.1 cos omega, which is 2 pi, sorry, omega, which is pi over 2. We are going to get that as pi over 2 times c. That is the equation of motion. Jedidiah?
Yes, sir.
Do you get it now?
Say a little.
Okay, no problem. I can go over it any number of times for you to understand. So let me point out, let me know where the problem is coming from. Then I can spend some time to deal with that. Yes.
Sir, what I heard you say is that you said that if it's at its maximum displacement, then y is a sine, a cos,
No.
a
Yes.
cos omega t.
Yes.
So you said when it's in what, that it will be a sine omega t.
When the particle is passing through the equilibrium position.
Okay.
When the particle is passing through the equilibrium position,
Okay.
that is where we have the equation as y equal to a sine omega t. Okay. Elisa, welcome back.
Thank you.
I heard your message, but when you were calling, I didn't know that you were ready to receive a call. Anyway, I am recording the lesson. So
yes.
When I finish, we'll have a way of getting it to you, okay?
Yes, please. Thank you.
All right. You're welcome. This is the equation for the instantaneous displacement. Now, the next question is, we should calculate the time it takes before the displacement becomes equal to 0.075. 0.075. What time does it take before the displacement becomes 0.075? What we are going to do is to substitute the value of the displacement, which is 0.075, into the equation we have found. If we do that, we're getting 0.075. This is equal to 0.1 cos pi over 2t. We now have a duty to solve the trigonometric equation there. How do we do it? We're going to write cos pi over 2t. Let me put that in the bracket. This is equal to 0.075 over 0.06. Can you do the evaluation for us? 0.075 over 0.06. Hello? 0.075 divided by 0.06.
1.25.
You have 1.25. Okay, so we're going to have 1.25. All right, that is what we have, but we haven't finished. We want to get a time. So let me continue on my right. You have cos pi over 2 times t. This is 1.25. We want to work out the t. So what should we do? We want to get the value of t. Don't forget the whole of pi over 2t is representing one angle. So I think that it will be good if we put that in the brackets. I want to get the value of t. What should I do? Oh, I have cos pi over 2t is equal to 1.25. I want to get the did you people do oh, where are these students looking? We have made a mistake. You see, if we make 0 cos pi over 2t the subject, we are not going to get 0.075 over 0.062. Are you people there? Hey, let's look at the change of subject. Hello.
Right.
Let's look at the change of subject. It is what I've written is not correct. See, if you make cos pi over 2 times t the subject, you should get 0.075 over 0.1. So what do you get there?
$0.75.
Yes, 0.075. Are they? So we're going to have cos pi over 2t to be 0.75. Now, how do we get the t? We have spent quite a lot of time going through this. To get the t, we will first write that pi over 2 times t should be equal to cos inverse of 0.75. Use your calculator, find the cos inverse of 0.75. Don't forget that in the displacement equation, the angle in the trigonometric function is in radians. The angle in the trig function is in radians. And so we will have to program the calculator to see the angle in radians. All right. What is the cos inverse of 0.75?
0.7227. 7227.
0.7227. Okay, I will leave it here. You make theta, sorry, make t the subject or find the value of t. Jedida, are you there? Okay, Eliza, your hand is up. Go ahead.
Mr. Kofi, please, when you are working, when you are doing simple harmonic motion, is you compute everything in radian, or it's just the angle with the trig function?
Yes, if you have to do any calculation that will involve the trigonometric function, that will involve an angle. The angle is in radian. But if you have
every
to,
other thing is in degree.
yes, if it doesn't involve trig function. Let's look at this slide. If you look at what we have here, on the left, what we started with, we found amplitude. In fact, amplitude was given. We're finding frequency. You will see that in those calculations, because we did not have any trig function there was nothing like let's change to radian. But somewhere towards the end, where we needed to evaluate y equal to 5 sine, all those things, because the evaluation has a trigonometric function in it, we'll have to program the calculator to see the angle in it as an angle in radian. So if it involves the trig functions, then we'll have to change the mode to radian in order that it could be recognized as such. Okay?
Yes, please.
All
Thank
right.
you.
So what is t equal to? Oh, let's hurry up. Hello. What is t equal to? Jedediah, Cassandra, Elisa.
0.
If you make t the subject, you have what? 0.
4, 6.
4, 6. To the rest of you, is that answer correct?
Yes, please.
0.46 seconds. Okay, so that is the time it will take before the displacement becomes 0.075. Yes, Jedediah.
So you see, when you go the 0 point, so you see the second distance, the line, the middle part. 0.075 is equal to 0.1 cos pi over 2t.
Yes.
Now why didn't you just do 0.1 cos pi over 2? Then you get the numerical value.
No, we didn't do that because see, anything that comes after the ratio cos is to be seen together as an angle. In fact, you are to recognize, now let's go to the left, the very left end. You are to recognize the equation as A cos the omega t must be in bracket like this. Can you see? So anything coming after cos or sine must be seen together. So we cannot evaluate the function using part of it and leaving the other part. No. So we do not have found 0.1 cos pi over 2 separately and multiply the result by t. No, the pi over 2 and t are to be together. Maybe I have to put that in a bracket now. Do you get it? So all those confusion can be avoided. Is it okay now?
Yes, sir.
Okay, so that is T. The next question, what does it say? We should sketch a displacement time graph for 4 cycles of the motion. Can I go to the next page, please?
Please wait.
Jedediah.
Yeah, I'm writing it or I'll go confused.
Yo, I'm waiting for you to finish.
So yeah, I'm done.
Elisa, are you done?
Yes, please.
And Cassandra, what about you?
Yes, please.
Okay, so let's go to the last question. It says we should sketch the displacement time graph for 4 cycles. So our graph will have the displacement on the vertical axis, y in, what was the unit of measurement of the y from the original question? Y was measured in what unit?
Meters.
So we're going to have y in meters and time in seconds. Now, because the trig function is a cos, we are going to draw a graph which has the shape of the cos function. So our graph is going to be like this. This is 1 cycle. Two cycles. 3 cycles. 4 cycles. Now on this graph, we are to show the amplitude. What was the amplitude of the graph? The motion, sorry, the amplitude. Amplitude of the motion.
So 0.1.
So we're going to write 0.1 here. Apart from the amplitude, which is 0.1, we are also to indicate the period. The period is the time covered in 1 cycle. So if we are able to identify one cycle is going to be here. Let me put the mark there. So this mark is going to be the period. What is the period according to the question, the period was what? Oh, class, what's the period?
There are 4 seconds.
So we are going to put 4 here. We can get other marks clearly labeled. The time taken to make one cycle is 4 seconds. So the next mark is going to be 8. The next one is 12. The next one is 16. So this is the displacement time graph for 4 cycles of the motion. Can we go to the next question, please? Yarida, can I go to the next page?
Sir, please, yes.
Elisa, can I go to the next page?
Yes, please.
And Blessing, can I go to the next page? You respond in the chat. Okay. So let's go to the next page. We are going to try another question. I hope that this one, we will do it fast enough to be able to finish on time. I have just about 25 minutes and I don't expect to stay beyond that time. The next question is this. A particle is doing SHM. A particle is doing SHM. And its displacement y at any instant is given by y equal to a sine 2.5 ft plus 0.6, where A is the amplitude, measured in meters. T is measured in seconds, and F is frequency in hertz. Okay. Now the information that is provided is this. Yes. Elisa.
Mr. Kofi, please, can you read what is in the bracket for me?
2 pi ft plus 0.6.
Thank you.
Okay, so let's continue. When t is equal to 0, y is 2.5 meters. When t is equal to 0, y is 2.5 meters. And the velocity is 4.6 meters per second. When t is equal to 0, y is 2.5 meters and the velocity is 4.6. Question I, calculate the values of A and F. calculate the values of A and F. Then I calculate the velocity, and acceleration. Calculate the velocity and acceleration of the particle. Calculate the velocity and acceleration of the particle when t is equal to 2 seconds. Good. This one we'll have to do it as quickly as possible. I'll read one more time. A particle is doing SHM and its displacement y at any instant t is given by y equal to a sine in bracket 2.5 2 pi ft plus 0.6, where a is amplitude measured in meters, t is measured in seconds, f is frequency in hertz. When t is equal to 0, y is 2.5 meters and the velocity is 4.6. We should calculate the values of a and f and the velocity and acceleration of the particle when t is 2 seconds. How do we go about this? We have an equation for the displacement, and that equation is y is equal to a sine bracket open 2 pi ft plus 0.6. What are the conditions? It says that when t is equal to 0, when t is equal to 0, y is 2.5 and velocity is 4.6. We are going to use these conditions to determine some of the unknowns. When t is equal to 0, y is 2.5, velocity is 4.6. We are going to write when t is equal to 0, y is 2.5. So what do? We are going to put in 2.5 where there is y. We are going to put in 0 where there is t. And then we evaluate the equation or the expression. So write 2.5. This is a sine bracket 2 pi times 0 plus 0.6. We'll take our time and evaluate the expression in the bracket. We're going to have 2.5 a sine. Now, the one in the bracket, 2.5, sorry, the one in the bracket is 2 pi times 0 plus 0.6. Let me ask, if you evaluate the one in the bracket only, what do you get? Jedediah? What you find in the bracket, if you evaluate that alone, what do you get? Jedediah, are you there? Let's go to Elisa. Elisa, 2 pi times 0 plus
0.6.
What do you have?
0.6.
You have 0.6. Okay. So we are going to solve for A. How do we solve for A? We make it a subject. So you have A equal to 2.5 over sine 0.6. Again, in this equation, we have a term which is trigonometric. And so to evaluate that expression involving the trigonometric term, we know what we have to do. Yes.
Please, can I be excused for 2 minutes?
No problem.
Thank you.
So we are going to evaluate that expression 2.5 over sine 0.6. But don't forget that the angle 0.6 is in radian. So you have to program the calculator to see that as an angle in radian. Good. Elisa, Can you work that one out? Betsy, also work it out and put your answer in the chat box. Okay, so what have you got?
4.46.
4.46.
46.
Meters. Is that correct? Jedediah, is that the answer you got? What about Blessing? Blessing, did you get his answer? I'm not getting any response from them. What I will ask is for Elisa to check it one more time. I'm not saying it is wrong, but we just want to be sure that what you have put down is truly the correct answer.
Mr. Kofi, please, the only part we are computing in radian is the sine. That's the only part.
Yes.
Okay.
Yes. So you can just change the mode to radian, and when you type 2.5 over sine 0.6, it is only the sine 0.6 which it will see as an angle in radian. The 2.5 is a number, it's not an angle. Okay, is that correct? Can you confirm the answer?
4.43.
4.43. All right, so let me make the correction. 4.43. Okay. So that is the amplitude. We want to get the frequency. We have used those conditions, t equal to 0, and then the displacement. But the velocity is not directly captured in the displacement formula. If we go to these pages, let me take you there. If we go to these pages, no, not here. We can even find one here. You will see that in working out the velocity, we need omega root of a square minus y square. Can you see it? That is the relation which has velocity and other quantities in it. So we are going to go for that. We write v is equal to omega root of a square minus y square. Now, when we make the substitutions, we can get omega. Once we get omega, we'll be able to get the frequency. So let's make the substitution. Velocity is 4.6. We have 4.6. This is omega root of e square, which is 4.43 square, minus the displacement that was provided, 2.5 square. Good. So you work out the value of omega and let me know that value. Elisa. Okay, so have you got the value of omega? Elisa, have you worked out? Okay. Cassandra, you are back. So can you evaluate the expression there for omega for us? That is, if you make omega the subject, you will have 4.6 over root of 4.43 square minus 2. Okay.
Sir.
Jedediah, welcome back.
I have to do some 1.26.
What did you get?
1.26.
1.26.
Mm-hmm.
Jedediah, are you sure? I don't think so. See, 4.43 square minus 2.5 square. You take the square root.
Hey.
You should get a smaller number. So 4.6 divided by that square root. I don't think it's 1 point, whatever you say. Check again. Cassandra, can you also work through that evaluation and get us your answer?
Akofi is right.
He's right.
1.26. Yes.
1 point what?
26.
I see. Okay. So 1.26. Now the frequency is contained in omega. So we have but omega is 2 pi f. So our f is going to be omega over 2 pi. Our omega is 1.26 divided by 2 pi. So what is the frequency?
0.2.
2 hertz. That is the frequency. Great. Let's try and finish it quickly and close. We want to calculate the velocity and acceleration when t is equal to 2 seconds. So now the equation becomes y is equal to the a, we got 4.43. So it is going to be 4.43 sine 2 pi. The f is 0.2. So let me write 0.2 t plus 0.6. In fact, we can further write this as 4.43 sine. It can be 0.4. You see, to be able to get the velocity, so we'll write 2 seconds. Displacement sine 4.43 sine 0.4 pi by 2 plus 0.6. Don't forget, all that angle is in radian. Okay, kindly give me the value of the displacement.
Mr. Kofi.
Yes.
0.125.
0.125 meter. Any confirmation? Any confirmation? Elisa, Jedediah, and Blessing. Any confirmation? Cassandra, can you evaluate it one more time? I'm not saying it is wrong, but because your friends are not
Yes.
responding, just Is that answer correct?
Yes, sir.
Okay, so that is a displacement. Now we have displacement, so we want to get the velocity. What do? Our velocity is omega root of a square minus the y square. So it is now going to be omega, which we found to be 1.26. So 1.26 root of the a, we got 4.43. 4.43 square minus the y, which is 0.125. So 0.125 square. All right. So that will give the velocity. Mm-hmm.
5.58.
5.58 meters per second. Acceleration A is negative y. Omega square y. Okay, so we make substitution. We have negative, the omega is 1.26, 1.26 square, see where the square is, and the y is 0.125. The unit is meters per second square. All right, so that is the solution to the problem. Any questions? Yarida?
Sir.
Yes.
See the third part. Y is equal to the third column or the say y is equal to 4.43 sine, then bracket 2 pi times 0.2. Where did you get a 0.2 from?
Where did I get the
As I
0.2? You see?
Frequency.
Okay, that's fine.
Yes,
if you have seen it, that's okay. All right, any questions, please? I want us to end the lesson. Cassandra, any questions?
No, please.
Elisa, any questions?
No, please.
Blessing, any questions? Okay, Blessing has left. All right, so we'll end here, continue next week. I'll see if I'm able to put some questions together. The fact is, I am very, very occupied throughout the week, but I'll try find some time and get some questions for you. All right, so until we meet again tomorrow, it's a great day. Stay blessed. Bye-bye.